Hello, everyone. My name is Jack Knights. I am a 2017 graduate of Canisius College and an undergraduate admissions counselor for Canisius. Today with us, we have Dr. Wood and Dr. Ertor from the Physics and Pre-Engineering Department. Dr. Wood, I'll hand it over to you. You have a presentation here for us.
Thank you very much. Yeah, my name is Dr. Michael Wood. I am the chair of the physics department and director of the pre-engineering program here at Canisius College. Just a little background about myself. I got my PhD from the University of North Carolina at Chapel Hill, and I specialize in experimental nuclear and particle physics. Actually, Aaron, do you want to introduce yourself?
Hello, this is Erden. So I studied physics. I started with physics and I did experimental particle physics. And then I switched to engineering and I did my PhD on biomedical engineering in the University of Western Ontario in London, Ontario, Canada. And I've been doing research on lasers. So material processing with lasers for some biomedical applications, also some industrial applications. So, yeah.
Great. Thanks. Yeah, I can tell everybody a little bit about our department here. But first, I usually want to, talk about physics and engineering in general before I start to kind of focus in on Canisius. And, physics and engineering are great professions. Even in the best of job markets, physics and engineering is good. On unstable job markets in our current situation, they're still excellent careers, whether you're interested in physics or you're interested in engineering. And what I like about physics and engineering is that they give you a tremendous amount of flexibility. As you'll see, I'm going to give a little presentation in a second. But physics and engineering have problem-solving skills that we impart upon you, mathematical skills, quantitative skills, and computer programming skills. Kind of as an example of the flexibility that you would get. Like I said, I'm a nuclear and particle physicist, but during this kind of time of quarantine, Dr. Ertor and I we kind of volunteered our time with a group down at University of Florida that is looking to make an inexpensive ventilator. And the one way that we can contribute as a physicist and engineer is with one of these little things right here, which is an Arduino microprocessor. And so while I can't build a ventilator in my basement, I can at least work on the, testing the programming, testing the code that they have, because something like a ventilator is a device that you really want to make sure works all the time. And so we've kind of volunteered our time and our skills beyond what we usually do on that kind of a project. So what I can do now is, I guess, share my screen and kind of go over this presentation that I have.
Good.
So, so I just want to give you an overview of what we offer here at Canisius in terms of physics and engineering. So what I usually like to talk about first, the question I often get when people ask me is, what's a physicist? And so there's this quote by this guy, Albert Einstein, who said, "The supreme task of the physicist is the discovery of the most general elementary laws from which the world picture can be deduced logically," which sounds rather impressive. But, really, if somebody asked me, we want to study the universe. We want to study the world. We want to study nature. We want to study the things that are moving around us, the planets, the stars, but also, cars and trains and airplanes. Even things like building a bridge, which we don't want to move. We want to make sure that we know what we're doing when we build it, so it doesn't move. So the difference between like an engineer and a physicist is an engineer kind of takes that knowledge that physics is trying to understand about the world and then apply it to something practical. You want to, to build something that somebody else wants to use, that can, make the world a better place. And so engineering is kind of like applying that physics knowledge and making it useful for others. That's another question I often get asked is, about is the fact that, who is a physicist? What are some examples of physicists? And a lot of times we point to the people that you usually see, which are kind of celebrities in the physics world. So you got guys like Stephen Hawking and Albert Einstein and Marie Curie. But there are other noticeable people, like Sally Ride, the first female astronaut, was a physicist. And then Moore from Moore's Law and the computing, as well as these two guys in Hollywood, Mike Judge and Dave Cohen. So even though they are physicists, they went on and went into the movies and TV business. Brian May, one of the guitarists for the band Queen, has a PhD in physics. And even some politicians got their start in physics and then transitioned over to into politics, like Angela Merkel or Jimmy Carter. So really, what I'm kind of this argument I'm making is that physics gives you a good foundation, and then with that you can try and do whatever you want to do. So the other thing I did was to look at what kind of jobs physicists and engineers have. And so I just went into LinkedIn and typed in, physics jobs. And some of the things that came up are like data science for Fortune 500 companies. You have patent scientists, patent lawyers. Even things like companies in the aerospace industry, looking for physicists. So this one's a hospital. So this Massachusetts General Hospital is looking for a physicist to work in their radiation oncology department. And Ford Motor Company. Ford Motor Company is looking for a research engineer or scientist to actually work in their, if you read the fine print, to work in their AI group, to look at artificial intelligence and how it can be applied to their car designs. Well, this is, if you like video games, Sledgehammer Games is looking for physicists to make their video games more realistic, and also the government, like the CIA, puts physics and engineering down in their list of what they're looking for in future employees. So physics and engineering are a great preparation, so some of the things I like to say is that physics actually matches well with other disciplines as well. So if you're thinking about something like going to med school, physicists high score at the top of the list when it comes to things like the standardized test for medical school, the MCAT. They're at top of the list for the LSAT for law school. So what our department is doing is trying to prepare you for whatever career path that you have in mind. So we have faculty that do research, research in nuclear and particle physics. Aridin is, researching in biomedical engineering. And, I've been funded to do my research. And I've sent students off to other places to work on projects, like the University of Notre Dame or Genoa, Italy. Okay, so now what I do is kind of talk about the individual programs that we have at the department. So the first is our Bachelor of Science in Physics. That one is really a preparation for graduate school. So if you're interested in getting your PhD in physics, then you would go with the Bachelor of Science. You would get very in-depth education in all of the different topics like mechanics and electricity, magnetism, quantum mechanics. And we also try and get you involved in some kind of research. So you can test out whether or not independent research, do you want to be a researcher? So another program is our Bachelor of Arts program. This one is, you do not have you don't go into as depth as the Bachelor of Science program. This is more of a broader education in physics. But it does give you the flexibility that if you want to double major, if you want to get a major like physics and biology, physics and chemistry, physics and computer science, physics and English, if you want to be a science journalist, then the Bachelor of Arts kind of allows you to do both, to follow your love of physics and to follow your love in another field. So, a lot of the skills that you would get in physics that you wouldn't see at other places or other studies. So we're really strong in math. So, the only other people who take more math than us are the mathematicians. You get a strong background in computers. The only other people who do more with computers are the computer science majors. And being mathematical, it's a very quantitative science. And we really try and promote those critical thinking and problem solving skills. We want as physicists to solve problems, to figure out how things work. And then we also, at least here at Canisius, promote research. We want to give you the opportunity as an undergraduate to get involved in research. So what we also have is our pre-engineering program. And because what you'll find is that if you look at a freshman and a sophomore curriculum in engineering at any engineering institution, it is pretty similar to that of a physics curriculum. The engineers have to take 4 semesters of calculus, and the physicists have to take 4 semesters of calculus. The engineers have to take a course in programming, just like the physics majors. You have to take introductory to chemistry. And so what we have is this program where you can get your start at Canisius, get a lot of those introductory classes, and then transfer after your sophomore year or after your junior year, and finish up your engineering degree at another school. So with our pre-engineering program, you don't actually get an engineering degree from Canisius. You would get that from whatever school you transferred to, but you would get a good foundation in an environment that would help you to succeed. So, at Canisius, we are a small institution, and I've never taught a class that had more than, say, 25 students in it. So it's this small class environment, this environment where the faculty member, like myself, can have a lot of interaction with the students, get to know the students, to help them with whatever problems they might be having, or try and guide them a little bit. So that's what our department has to offer. So our 2+2 program is 2 years at Canisius, freshman, sophomore year, getting your foundation, and then transferring and finishing your engineering degree in your junior and senior year. So we have a 3+2 program where this is more of like a double major in physics and engineering. So you would spend 3 years at Canisius getting that introductory sequence, and then you would take your third year, your junior year, where you would now focus on the physics courses, and then transfer to the University of Buffalo, where you would then spend another 2 years, effectively your junior and senior year in your engineering program. And then we would transfer back courses from UB to satisfy the senior year of the physics degree at Canisius. So again, it gives you a chance to double major in physics and engineering. And this is primarily for programs in civil, mechanical, electrical engineering. So the last program we have is kind of a combination of a bachelor's, master's degree, where you get your bachelor's degree in physics, and then you get a master's degree in education. So you would spend 5 years at Canisius, so it's 4 + 1, 4 years working on the physics degree, and then 1 year to complete the master's in education in special education. And with that, you would then basically prepare yourself for going out and teaching high school physics. Okay, so what we really pride ourselves on is the ability to get our students into research. We, as faculty members, we have active research programs. I typically work with 2 or 3 students a year on my research. This is just a list of some of the people who have done research in the past. And here at Canisius, but also at other institutions. At the bottom there on the left, Kevin Howard, who graduated in 2015, did a summer at the nuclear lab at University of Notre Dame. On the right-hand side, Christine Coulson, who graduated in 2016, she did a summer at Baylor University in Texas with their astronomy group. So, I think, I really push the students to get involved in research, start learning about physics outside of the classroom and get a chance to kind of look at something original. And so it's not just learning about what stuff that's in the textbooks, but also, tackling problems that are new, that have not been addressed before. So here's a picture of me and 3 of my students. During the summer, we went down and visited the accelerator where I do my research. It's an Electron Accelerator run by the Department of Energy down in Newport News, Virginia. So here we are standing in front of a large detector system, where this is the bird's eye view of that detector system, where we were standing in front of that big kind of reddish orange cylinder, which is a very large solenoid magnet, where the electron beam would come from the upper part of the screen and then collide with the target, and then all of the particles would come out and go into the detector and be reconstructed to figure out what's going on inside the nucleus. So that was a good time. They got to take a tour of the lab. They got to meet other physicists. They got to see what a national lab looks like. All right. So this is just a list to kind of show where some of our students have gone, what they do when they've completed, and it basically breaks down into kind of 2 or 3 categories. A number of them have gone on to graduate school and to work on their PhDs. Others have gone into industry. Most of the list in the name of most of the people listed under the industry, like Aaron or Daniel, are actually part of our 3+2 engineering program. And one thing I did want to highlight is that we have this seminar class, really, where every Friday in the semester we will either give a talk or we'll invite someone in to come and give a talk to kind of give to talk about a wide variety of topics. And so we've had invited speakers from companies from around the Buffalo area, a lot of engineering companies and manufacturing, like Moog or Energy, and they've come to, one, to give the students, the broader picture of what is possible out there with your careers, but also kind of talk about some interesting, technical and scientific topics. So we do this every year. So every Friday we have a seminar for all the students and the professors to come and learn about something that you wouldn't get in your other classes. So I kind of wanted to end my talk is that to advertise this, and that is the Lee Foundation has a scholarship here at Canisius where they offer 2 scholarships every year of $10,000, and it's only restricted to students who want to study physics, mathematics, computer science, and finance. So when you're applying to Canisius, the deadline for these scholarships, the application is in March. So if you're applying next year, just keep a lookout for the Lee Foundation scholarships. And if the Lee scholarship has been around now for 3 years, and every year now, one of our physics majors has won it. So this is our 3rd year running, and we've had 3 in a row. So we're 3-0 when it comes to the Lee Foundation scholarship. So if you want to find out any more about our department, you can check us out on the web. And you can also follow our Twitter account at CanU Physics. So anyway, I appreciate you hearing our presentation. If you have any questions, I'd be happy to answer any of them.
Yeah, everybody that's watching, if you have any questions, feel free to put them in the question and answer section there. I think you guys cover a lot there, Dr. Wood, with all of the questions that somebody might have about physics. So I think you covered a lot. So we don't have any questions right now, but we'll give it a little bit if you want to add anything.
Well, actually, I wanted to maybe toss it over to Airden, and if he wanted to talk about some of the activities going on in the Buffalo area.
Sure. Thanks a lot. So Buffalo is a great place actually right now. So there is a lot going on in the industry, also biomedicine. So we are well connected with the both fields. So we are inviting guest speakers, and we are planning to start some collaborations. So doing some applied research at Canisius. So, and we know that in 5 years from now, most of the people are gonna be retired in engineering and physics. So most of the companies are start to look for replacing their workforce. So I'm in touch with them. So and it's a great time to become an engineer or physicist. So we are well connected with them. So we will be collaborating and we will be doing a lot of projects together. So just keep it in mind. And Buffalo is growing, so this is pretty good news for us. So yeah, if you have any questions about Buffalo industry and Canisius and all the connections, you can ask. Thanks.
Great. Awesome. So no questions in here. So I think I'll end it here, but thanks to Dr. Wood and Dr. Ertor for joining us today and giving their time and their busy schedules. And thanks to everybody that attended as well. If you're a senior, definitely thinking about making that decision right now, definitely reach out to the admissions office and help you in making that decision. And if you're a junior, come visit campus whenever we open back up here. It's the best way to figure out if you like the place, and you'll get to see your professors and just get a feel for campus. So that's the best advice I can give for anybody. But anything you guys like to add?
No, I think that pretty much covered it. And no, I appreciate the opportunity to reach out. And like I said, if anybody is interested in talking about physics or engineering, we'd be happy to answer your questions. So.
All right, good stuff. All right, thanks everybody.